5, exponent laws 2. We took a look at our very first power. Same base, add exponents. Same base of 5, we add the exponents to get 15. Which power law is this one talking about? Which power law is that one talking about? Okay, subtract the exponents. Because I'm doing what? What does the fraction line mean? Division, good. So as long as I'm dividing, and I've got the same bases, I can subtract exponents. So that's going to give me x to the m subtract n. As an example, I could have 4 to the 12 divided by 4 to the 8. And what's that going to give me? 4 exponent 4. Good. I'm going to subtract my exponents. My base stays the same, and I get 4 exponent 4 when I subtract the exponents, okay? So all I've done, the base is the same. So I keep my base, the big 4 stays. I take the 12 now and subtract the 8 because that's the same base. I take the little numbers, the exponents, and I subtract them. So 12 subtract 8 gives me the 4. So that would be my final answer in exponential form. Now, if they say simplify completely, on my calculator, I would go 4 times 4 times 4 times 4, or 4 exponent 4 to get your answer for that. Okay? Let's take a look at the next one. X exponent 0. What do we know about the 0 exponent law? It's always 1. So do I write x to the 1? No, I just wrote a 1 there. How come? Because this all gets replaced. X to the 0. Anything exponent 0 disappears, and it gets replaced now by a 1. Okay, its answer is a 1. Okay, now we can remember how that works. What is a pattern to show us the 0 exponent law? Let's take a look. I've got 2 cubed, 2 squared, 2 to the 1, 2 to the 0, 2 to the negative 1. What are my answers for these? 2 cubed gives me 8. 2 squared gives me 4. 2 to the 1 gives me 2. What have I done every time? I've divided by 2 every time, so you're going to divide by the base. Okay, so you're dividing by the base. So I'm going to keep dividing by 2 every time. If I take 2 and divide by 2, what do I get? 1. That's why anything exponent 0 equals 1, because they're dividing by that base every time. So if I take 2 and divide by 2, I get 1. If I take 1 divided by 2, what do I get? 0.5, 1/2. So that means the negative exponent here is going to give me 1/2, 0.5. Okay? That's how our pattern works. We divide by our 2 every time. Okay? Alright, let's take a look at some more exponent laws. The next one. It says expression 2 cubed, all squared, is known as power of a power. So this is our power of a power law. Now, what does the word of in math mean? What do you remember? Multiply. Good. So, of means multiply. So we're saying we're taking powers and timesing by powers. So in order to simplify and get rid of the brackets, I take 2 and I times it by the inside exponent. So any exponent on the outside you times to the inside, and that removes your brackets. So we can read it as 2 cubed squared, or 2 raised to the power of 3, sorry. I should say raised to the power of 3. So we have 2 raised to the power of 3. Okay. What's that, sorry? Oh, sorry, yes, sorry. The 2 is on the outside. You are right. Absolutely. I was just looking at this here, the inside exponent. So this is 2 to the power of the 2 cubed, which is 2 raised to the power of 3, but then it's all squared. So they want all of this squared, which means I have 2 sets of those. So I would write 2 cubed times 2 cubed. That's my repeated multiplication. That's what we actually write down, because it's outside 2 is telling me I have 2 sets of those. So if I have 2 sets of those, now I'm back to my adding law, where I can add exponents because I'm multiplying the same bases. So that's going to give me 2 exponent 6. And what do you think I would do if I multiplied these up here? I multiplied 2 and 3, what do I get? 6. So you get the same answer if I just multiply the outside exponent to the inside. So now what is this guy telling me? How can I write him as repeated multiplication? What is the outside 4 telling me? Yep. The exponent is what's right?
It's not 34.
The exponent's not 34, good. Okay, because I've got a bracket separating them. What else do I know? What else do I know? Yep.
That in the multiplication, you write the base and then like negative 4 cubed 4 times.
Right. This is saying I've got 4 sets of all of that. So I'm going to write negative 4 cubed 4 times. That's what the outside 4 tells me. That's his job. He's saying you have 4 sets of those. Now, as repeated multiplication, can I solve him in exponential form? Yeah, I can. So what would be my top exponent, my little baby exponent on here if I solve this? What would it become?
12.
It's going to become 12. So I'm going to take a look at these, and I add my exponents, and I'm going to get negative 4, all now to the exponent 12. Okay? That's what that means.
And you can also just multiply the remodel.
That's what we're finding is our,
That's just
that's our pattern, absolutely.
That's just a nice little shortcut.
It is a shortcut. So that's what we're going to write down for our power of a power law. So power of a power law says, to raise a power to a power, you multiply the exponents. And it's got our example here. A to the m in brackets with an n outside of brackets gives me AMN. When they sit side by side, what does it mean? Multiply, good. So that's what it's telling us right here. MN means multiply, they're timesing it. So it's saying that A, your base number, can be any digit but a 0. It cannot be a 0. And the M and N are whole numbers, which mean they can be a 0 or bigger, but they can't be any negative numbers. We don't deal with negatives till next year. Okay?
Wait.
So that's what we do.
So the answer to a power won't ever be negative because we don't do negative till next year. So I can rephrase that.
I was just saying that the exponents here, M and N, they won't be negative exponents.
It won't be negative.
No, not till next year. Okay, so those little baby numbers up top, those exponents, they're not going to be negative till next year. Now, they might throw a couple of negative ones in there to add or divide out, because those can be possible, but you're always going to end up getting a positive answer in the end. I'll show you. Here's an example. If I've got 4 squared, or actually 4 to the negative 2, times all to the negative 3. Well, we usually don't deal with negative exponents, but what do we know about a negative times a negative? It's going to give us a positive. So I could multiply those two together and get 4 to the positive 6. Because 2 negatives, when you multiply, will give a positive answer. Okay?
But you won't ever have one positive.
You'll never have one. Well, you could have a positive and a negative if it's like this. If it's dividing. So watch carefully. If I've got 2 to the negative, or positive 7, okay, 2 to the positive 7, divided by 2 to the negative 3. Well, when we divide, we subtract exponents. So that's actually 7 subtract negative 3. And what do I know about 2 negatives in the middle?
You make them positive.
They change to positives, yes. So these will change to positives, so it'll end up with as a 10. Okay? So your answer will be 2 exponent 10. Okay? So the only negative they're going to give you is where it can form a positive in the end. Okay? Does that make sense? Okay. Well, let's move on to the next question. So, first of all, when you do the multiplying of your exponents, it removes brackets. So multiplying the exponents, removes the brackets. We can't forget that because that helps us simplify sometimes. Okay, so it helps us simplify. Unless there's another bracket separating a negative sign, which sometimes we see. Okay, so when we multiply that outside exponent in to the other exponents inside, it's going to make the brackets disappear. Okay, let's take a look at the next part. The base of a power might be a product. Product meaning there's two different bases inside. Okay, if there's two different bases, I can't combine them because they have different exponents. Okay, if I'm using my exponent laws. Now, there's two ways to solve them. But let's try and solve it as exponent laws. So right now I've got 2 times 3. That's my base inside. So our times sign is a little dot there. So that means I've got 2 times 3, and I've got 2 sets of them. 2 times 3. I have 2 sets of both of those. And don't forget, I've got hiding 1s on the 2 and on the 3. So that's now going to simplify to give me 2 times 3. And now I'm going to add the exponents. How come? Because I'm multiplying. When it's side by side, it means multiply. So you take the ones of the same base. I look at my 2's. They're the same base. I can add the 1s on top. So that's going to give me a 2. Then I look at my 3's. The 3's the same base. I can add the 1s on them. And I get a 2. Right now they're all 1s. So adding 1s will give us 2 anyways. But if they were different numbers, you have to know which ones you can add to. All right. Let's take a look at example 4. What does this actually mean? It means we've got 6 sets of those. Well, an easier way would be me to put the hiding 1s on there. And what did we do with an outside exponent before? What did we do to that exponent to get rid of it and to remove the brackets? What did I do? I multiplied it in, didn't I? So I'm going to multiply it in again. I'm going to take that 6 times my 1 and the 6 times that other one. And now I'll get rid of my brackets. So now I've got 4. 1 times 6 is 6. So 4 exponent 6 times my other base 3. And it's got a 1 on it. And 1 times 6 again is still 6. So that'll be my final answer in exponential form. If it wants me to solve, I'm going to have to simplify the one on the left, simplify the one on the right, doing BEDMAS, and then multiply their answers. Okay? Let's try one more. Let's say I have this. 3 squared times 2 to the 4th all to the 5th power. This is where it gets important, that you know which bases are the same. So it's saying I have 5 sets of those. So what I'm going to do with the outside 5, who do I multiply it to? The exponents only. So I don't multiply it to the big numbers. So I only multiply it to those exponents on the inside. Okay? My base 3 and my base 2, they stay the same. So I keep my 3, and I keep my 2, and now I just multiply my 5 times my exponent 2 to give me a 10 on the 3, and I multiply the 5 and the 4 to get 20, and I put a 20 on that 2. And now I'm done. Okay, that gets rid of your brackets, and it's simplified in exponent form. Okay? That's where we're going with all this stuff. Does that make sense? Okay? Now, the same thing happens if I have variables. If I put, let's say, a letter x in there, let's say he was x to the 6, I would take that x to the 6, and that 6 would multiply by the 5 as well. Okay? And he would just sit in between them. Make sense? Okay. Let's move on. Now we want exponent law power of a product. These are some examples. This is what it actually means. This is what we're going to write down. So it says AB exponent m. So AB in brackets, exponent m. Gives us A exponent m times B exponent m. A and B can be positive or negative numbers, except they cannot be 0. And your exponents, again, must be whole numbers. Okay? So that's our power of a product rule. let's take a look at a few examples and see if we can solve these. Now the first thing you should do is always write in the hidden little baby ones you see for exponents. So there's the little hidden baby ones on the 2, the A, and the B. Now why would I draw those in? Why do you think I drew those in? That's right, because I have to remember I have to take that outside little 2, the outside exponent, and it has to multiply into every one of those little ones. So it has to multiply to all 3 of them, and that's how I remove my brackets. So now I'm going to have 2 squared, A exponent 2, B exponent 2. Right now it's solved in exponential form. There's only one thing I can do to make it go smaller yet. How can I simplify it even further? There's only one left thing I can do. Yes? Good job. So you're going to take in front, you're going to take a look at that 2 exponent 2. So any digits with exponents, you can solve those. So that's going to become a 4, and then I stick my A squared and B squared on right behind. Side by side, it all means multiply. That would be my simplified form. You try letter B, push pause now and play when you're ready. Okay, let's see what we have here. We have a 3 exponent 1 we can't forget about. And we're going to multiply the 2 into all, or sorry, the 4 into all exponents. So that's going to give me 3 exponent 4, A exponent 12, and B exponent 8. Who got that so far for an answer? Nice work. Okay, what's one step further I can go? One step further. Dylan?
4 times 4. Or the 3 times 4.
3 exponent 4, good. So 3 exponent 4 is going to give me 81, good. So I'm going to have 81, A exponent 12, B exponent 8. Okay? Let's move on. Okay, moving on. So we also know the same thing happens where we've got more than one thing in brackets. Before they were sitting side by side being times. Now they're sitting top and bottom. When they're sitting top and bottom like a fraction, what does that mean they're doing?
They're dividing.
They're dividing, good. Because this fraction line means division. So remember, I've got a hiding 1 on the 5 and a hiding 1 on that 6. So now I'm going to take that outside exponent and I'm going to multiply it in. Same rules apply. But don't forget, it has to go to every single exponent inside, which means it's got to go to the 5 and to the 6 because they both have exponents. So this is going to give me 3 sets of it, because I have 3 sets of 5 over 6. So that's what it would look like as repeated multiplication. So when I multiply that in, that's going to give me 5 exponent 3 on top of 6 exponent 3. Good. Now, what's 5 cubed? How would I solve this? What is 5 cubed? 3 times 5 by 5 by 5. What do you get? 125. On the bottom, you have 6 times 6 times 6. 216. Good. Now, you're going to see if those will divide and go any smaller, and they won't. Okay, that will be lowest form. So if they say leave it as an exponential form, so simplify as exponents, that's your exponent form. This is called what form? What form do we call that, the answer? Standard form. It's got one other hidden name. Decimal form. Good. Okay, you guys try the next one. It says 2a over b squared. What do you know is hiding on the a and the 2? Little baby ones are hiding on there. Okay, you guys multiply that 3 outside into the brackets. And see what you get. Remove the brackets.
I understand the other part.
Okay, let's see how far you got. We're going to multiply that 3 on the outside to all the exponents inside, and that's going to give me 2 cubed over 8, and times 8 cubed all over b exponent 6. Now there's only one thing that can make that go smaller. What else can I solve in there? Dana?
Multiply 2 squared.
2 cubed, huh?
2.
Yeah, we're going to solve that part. So that's the only thing I can solve. So I don't know what A is, I don't know what B is, but I know that that's a 2. So that means 2 times 2 times 2, that'll give me 8. And then I stick my A and B where they belong. So A cubed on top, B to the 6 on the bottom. That will be my final answer. Okay? If they say leave it in exponent form, you want the guy on the left. If they say simplify completely or evaluate, you want the one on the right. Okay? All right. Let's move on and write down exactly what this law means. We can write down what the law says. So, power quotient law says A over B in brackets, exponent n, will give us A exponent n divided by b exponent n. And again, a and b can be negative and positive numbers. The letter n, the exponent, is going to be a whole number, of course, but the bottom can never be a zero base. Never have a zero on the bottom. Another example. 7 squared over 8 cubed, all to the 4th power. Well, that's telling me to multiply my 4 from the outside into the 2 and into the 3. Why the 2 and 3, not the 7 and 8? Because it's exponents times exponents. Okay, we never multiply by the big bases. So that's going to give me 7 to the 8 on top of 8 to the 12. Okay, that's solved in exponential form. Okay, you leave it as exponents. That'll give me a really, really big number on the top and bottom. So I'm just going to leave it in exponent form. That's just an example. Okay? Let's take a look at how we can solve this 2 different ways when we don't have variables. So we can use the exponent laws on the left-hand side. On the left-hand side, I've got a hidden 1. I have a hidden 1 on my 7 and a hidden 1 on my 5. So I'm going to multiply the 2 into my 1s. That gets rid of my big, big bracket. The bracket around the negative 7 stays because that's just telling us that it's a negative base. So it's going to be negative 7 squared times by, or 5, and it's going to be also squared. Now I can solve both of those because they're digits. So I use my exponent, or my bedmass rules, which means I have to solve the exponents before I can multiply them. So I'm going to solve my exponents. A negative 7 times a negative 7 gives me how big? Positive 49. And how big is 5 times 5? 25. So I'm going to have 49 times 25. So I want you to multiply 49 times 25 and see what you get. Sure, what'd you get? Yes, 1,225. Now let's take a look. We can do it the same way on the right-hand side by doing bedmass. Bedmass means solving the bracket first. So that means I'm going to multiply those two digits. So a negative times a positive will give me a negative answer. My big square brackets are still there. I get negative 35 in my big square bracket. Now it's saying it's all squared. I put my 2 back on it. So I have 2 sets of those. So I would take negative 35 times negative 35. That's going to give me 1225. I get the exact same answer depending on which way I do it. I can use it by exponent laws or I can solve it with bedmass. You get the exact same answer. Okay, let's take a look and see what you did. If I put a little 1 on those guys, I multiply my 4 in. So I'm going to have 24 exponent 4 divided by negative 6 exponent 4. That's going to give me, yes. Yeah, it's a big number, isn't it? Oh. So, I have 331,776 divided by 1296. Now when I divide those out, what do I get? 256. Good. Now let's find the easier way to do it. Well, they're both kind of easy. It doesn't matter which way, really. So I'm going to take 24 and divide by negative 6. That's going to give me a negative 4. Now I'm going to go exponent 4. That's going to give me a positive 256. Okay? All right, moving on. Okay, let's take a look at how we would solve these ones. Now again, using exponent laws or doing bedmass, it doesn't matter which way they solve it. Or this one wants us, it specifically tells us to do the exponent laws. So that means I'm going to need to do my exponent laws. So I have 3 squared timesing by 2 squared. That's going to give me a negative floater. That's going to take me to be 9 times 4 to give me negative 36. Okay, you put the negative floater on at the very end. Okay, any questions with that one? I'm going to do the exact same thing with letter B. I'm going to put a little 1 on the 78 and a little 1 on the 13. That's going to give me 78 exponent 3 over 13 exponent 3. Now here's some really big numbers. That's going to give me 474,552 dividing by 2,197. And I divide those out. And what do we get when we divide those out? Okay, so this is going to give us a 216 as an answer. Let's take a look at C and D. If we take a look at C, I have an outside exponent. I'm going to multiply the inside exponent. That's going to give me negative 5 exponent 6. So I type that into my calculator. It's a really big number. It's going to give me 15,625. Why is it a positive answer? Why did I get a positive answer?
Because the exponent's positive, I mean it's an even number.
Right, exponent's even number, and the negative is where? In brackets. Okay, it doesn't have a float or negative, it's got a negative in brackets. Okay, take a look at D. I'm going to do the exact same thing. I'm going to multiply the 3 into the 4. That's going to give me 3 exponent 12. With my float or negative, it's going to come down. So that tells me that my answer completely is going to give me a negative answer, and that's going to give me 531,441. Okay, let's take a look at our last two examples. If we take a look at letter E, it's got two parts, but they're separated by a subtraction sign. So by doing bedmass, I need to solve the brackets and solve the exponents first in exponential form. So I'm going to multiply the outside exponent into the inside exponents for both brackets to remove my brackets. So that's going to give me 3 to the 6 times 3 to the 9, which gives me 3 to the 15. Excellent. Now, I'm subtracting. On the right-hand side, I multiply my 2 in. I'm going to get 4 to the 6 times 4 to the 4, which gives me 4 exponent 10. Okay? Now I need to solve each one separately because I have to go by bedmass. Bedmass says exponents come before subtracting. So I'm going to solve 3 exponent 15. It's a very big number. Be ready for it. 1, 4, 3, 4, 8, 9, 0, 7. So that gives me 14,348,907. That's a big number.
Well, I'm just going to type that to my calculator.
That's what 3 exponent 15 gives me. Now I'm going to subtract what 4 exponent 10 gives me. So type in 4 exponent 10. It's a big number as well. See what you get for 4 exponent 10. 1,048,576. When I subtract them, look at what kind of number I get. 1,330,0,331. That's a big number as well. So I get 13,300,331. Do you know what that kind of number is? Where it starts with the same number, ends with the same number, and it goes evenly until the middle. Do you know what that's called? No? It's called a palindrome. It's called a palindrome number. Okay, and that's where the number increases with the same numbers and then reverses by the same amount of numbers. Okay? So all the numbers are identical going forwards and backwards. Doesn't matter which way you go. Okay, we have lots of words like that too. Yeah? Now what do you know about letter F? What do I have on my exponent there? It's a 0. So what's my answer automatically? It's a 1. Good. Okay, I have one question that I want you guys to do. Put that one right there. Okay, you guys try this one on your own. 6 times 7 squared plus 3 to the 8 divided by 3 to the 6 all cubed. Give that one a try. Push pause and push play when you're ready. Okay, now you've got a couple minutes to take a look at that question. Let's see how far you got. You should get 6 squared times 7 squared, adding 3 exponent 2 all cubed to give us 36 times 49 plus 3 exponent 6. 36 and 49 multiplied are going to give me 1764, and 3 to the 6 gives me 729. I add both of those and I'm going to get 2,493. Check your work, make sure you got the correct answers and see where you made your mistakes. This concludes lesson 1-5, Exponent Laws, part 2.